କାର୍ଯ୍ୟକ୍ରମର ସହ ପ୍ରାୟୋଜକ ହେଲେ
Good afternoon, my dear all students. I am Debasish Mohapatra, lecturer in mathematics, Jupiter Group of Institutions. Today, we will discuss about two-dimensional coordinate geometry. We will discuss about two-dimensional coordinate geometry. Two-dimensional coordinate geometry. This is also called geometry of R square, or we also call it as Cartesian coordinate geometry. Cartesian coordinate geometry. Cartesian coordinate geometry. So, Cartesian coordinate geometry, actually this is as per the name of René Descartes, the French mathematician René Descartes. He actually made a very beautiful job. He gave a link between your Euclidean geometry and algebra. So, that is why as per his name we call it Cartesian coordinate geometry. And geometry of R square, we will discuss why it is called geometry of R square. Before that, let us discuss what is a number line. You all know what is a number line. As we all know, say a straight line has infinitely many points. Also, we have infinitely many real numbers with us. So, what we do? We take a straight line, put 0 here, then we put numbers in equal gaps, positive towards right of 0 and negative towards left of 0, and in between 0 and 1 there are again infinitely many real numbers, infinitely many real numbers. As we all know, between any two real numbers there are infinitely many real numbers, they are densed. So, what we do? We link every point of the straight line with a unique real number, and that is we call a number line or a real number line. Next, what is R square? R square means it is the Cartesian product of the set of real numbers R with itself, where R is the set of real numbers. If you can recall, Cartesian product, again as per the name of René Descartes, say Cartesian product of two sets is, this is set of all ordered pairs x y such that the element x is present in A and the element y is present in B, set B. So, element x means the first element is present in the first set, x is present here in A, y is present in B, the second element is present in the second set, and that is the order here. What we say ordered pair? By order we mean ki the first element is present in the first set and the second element is present in the second set. So, likewise in R cross R or in R square, the points will be in the form of ordered pairs, and there is again infinitely many ordered pairs, many such ordered pairs. If you take R square, say that is R cross R, where R is the set of real numbers, that is set of all ordered pairs x y is such that x belongs to R and y also belongs to R for all such x y, for all x, for all y, for all x in R and for all y in R. Now, let us move to our coordinate system. What is the rectangular coordinate system or we say this is the Cartesian coordinate system. The Cartesian coordinate system. What we do here? Now say this is the plane of this whiteboard. We take two mutually perpendicular lines. Let me erase this. We take two mutually perpendicular lines. These are again real number lines perpendicular to each other. Say this point of intersection be O. This line is suppose x o x dash. This is suppose y o y dash. This point of intersection is called our origin, and so what we do, x o x dash and y o y dash, these are two mutually perpendicular straight lines intersecting each other at O, where O is called the origin or origin of coordinates. We simply call it the origin or simply the origin. Now this x o x dash, we give it a name. X o x dash, we call it x axis, y o y dash, we call it y axis, and together we call them x axis and y axis. They both are called the coordinate axes. X axis and y axis, they both are called the coordinate axis. Again, you know कि from origin towards x means in this direction, this is positive x axis, and from O to x dash in this direction, this is negative x axis. From origin to the upward direction means towards y, we take positive, and from origin towards y dash we take negative. So we say कि OX ray is positive x axis or non-negative x axis, we say, because origin is there, that is 0. OX dash is the negative x axis, OY is positive y axis, OY dash is negative y axis. So these are about the axis, the coordinate axis. So this side of x axis is positive, this side of y axis is positive, this OX dash direction we take it negative, and OY dash direction we take it negative. Now how to represent a point? As I told you before, कि the points in R square, they are represented by an odd pair. A point on the plane of R square is represented by an odd pair, of real numbers, Why it is called ordered, we will discuss. An ordered pair of real numbers. What? Now ordered pair of real numbers x, y, that means since we are taking real numbers, this x and y, both the coordinates, they are real numbers. So x here belongs to R, this set of real numbers, and y also belongs to R, this set of real numbers. And for the point xy, we say x is the x coordinate, or we say abscissa. X is called the x coordinate or abscissa. Similarly, y is called the y coordinate, or ordinate. What do you call? So, this x, this is x coordinate, and this y, this is y coordinate or ordinate, and this is the order how we write a point. Now, first we write the x coordinate, then we write the y coordinate. We do not change the order. If you change the order, it will mean a different point. It will be, say suppose somebody writes yx, this is not same as xy. We will discuss while locating the points, we will discuss. Now, we will discuss what are quadrants and signs. So, these two coordinate axes, they divide the plane, into 4 infinite regions. So, this region, this is called the first quadrant, this is called the first quadrant, or we write sometimes Q1, this is the second quadrant, or we write Q2, this is the third quadrant, or we write Q3, this is the fourth quadrant, or we write Q4. Here what we do, this x o y means this interior region, we do not take the axis, we do not take ox or oy or ox dash, we do not take that. Well, when quadrant we mean the interior region. If you consider this as an angle, say x o y, interior of this. So, that should be kept in mind, ki interior region of this, we do not go to the axis. Similarly, second quadrant means interior of this x dash o y, this side interior portion is second quadrant. Now, as this is the positive side of x axis and this is the positive side of y axis, in first quadrant if you locate a point, so the coordinates, their sign will be, how we locate a point we will discuss, but what about the coordinates, what about the sign of the coordinates? Here x coordinate and y coordinate both are positive, because ox is the positive direction, oy is the positive direction of y axis. So, the point, and we represent a point in the form of an ordered pair xy. So, in the first place we may have different real numbers, but the values should be positive in sign, and again in the second position we may have different real numbers, but the values should be negative, the values should be positive in sign, both the coordinates should be positive in first quadrant. Similarly, in second quadrant you see this is the negative side of negative side of x axis, and this is the positive side of y axis. So, in x we get negative values and in y we get positive values. Similarly, in third quadrant, say this is x dash o y dash, here negative side of x axis and negative side of y axis means the points will have, the coordinates will have signs both negative, x coordinate will be negative in nature and y coordinate is also negative in nature. Then what about the fourth quadrant, how what about the sign of the coordinates there? You can see ki this is the positive side of x axis, this is the negative side of y axis. So, the points, we first write the x coordinate, so x coordinate will be positive and y coordinate will be negative, because this is negative side of y axis. So, let me erase this. If we write a point as xy, in first quadrant in Q1 x is positive, y is also positive. In Q2 in second quadrant x is negative but y is positive. In Q3 third quadrant both are negative. In Q3 x is negative also y is negative. In Q4 x is positive but y is negative. So, these are the sign of the coordinates in different quadrants. Now, let us discuss some questions. If this is the case, now tell me, say point is 2 3, point 2 3 is in which quadrant? Point 2 3 is in which quadrant? We can see that this is positive, x coordinate is positive, y coordinate is positive. So, it is of the form plus plus. Now, plus plus means it is in first quadrant or Q1. It will be in first quadrant or Q1. Similarly, if you take say point 4 minus 5, it will be in which quadrant? You see, the x coordinate is 4 positive, y coordinate is minus 5, that is negative. So, positive negative is for which quadrant? This is for Q4 or fourth quadrant. This is for Q4 or fourth quadrant. Now, these are numeric values. Now, let us move into symbols. Suppose x is positive, y is positive. Suppose if x is positive and y is positive, what about the point x or minus x minus y? What about the point having coordinates minus x and minus y, say is in which quadrant? Is in which quadrant? Here you can see, as x is positive, so minus x will be, say x is positive implies minus x is negative, y is positive implies minus y is again negative. So, the point is actually having the sign, the coordinates are having the sign minus minus, because x is positive, y is positive. So, we get minus x is negative, also minus y is negative. That means minus minus means we are in which quadrant? We are in Q3. We are in Q3, the third quadrant. Now, suppose x is positive, y is negative, suppose, then what about the point x square plus y square minus x? X square plus y square minus x, what about this point? Means in which quadrant does this point lie? As you can see, a square quantity for a positive value x, x square is always greater than 0. Also y is negative, that means y square will be again greater than 0. So, x square greater than 0, y square greater than 0, that implies x square plus y square is again greater than 0. Now, x is positive implies minus x will be negative. So, now consider the sign of the coordinates. In the first x position, x coordinate position, we have positive sign, greater than 0 means positive, and in the y coordinate position we have a negative value. So, now if it is plus minus having that sign, this is in which quadrant? This is in Q4, the fourth quadrant. So, now we will take a short break. Stay tuned. Welcome back, students. So, we are discussing about the sign of coordinates in different quadrants. Now, let us move how to locate a point. How to locate a point in 2D. Say how to locate a point on the plane of R square. how to locate a point on the plane of r square, means the Cartesian plane. Now, suppose consider a point say p x y. For better understanding, let's take the point in first quadrant. So, let p x y be in first quadrant. In first quadrant means say x is positive, y is positive. So, to locate the point p x y, what we do? We say this is our starting point, origin is our starting point. From origin you move x units along x axis, you move x units along positive x axis, then you move y units parallel to positive y axis. Say if this is our this distance is y unit, whatever point you get, that will be our x y. So, what we do? We move x units starting from origin, we move x units along positive x axis, then from this point, say this is x, from this point you move y units parallel to positive y axis. We have taken y positive, so we are moving in the upward direction. Now, wherever you reach, that point will be x y. Conversely, if you say, what is important is, if this point is x y, now you see this distance is y unit and this distance is x unit. That means, for the point p x y, this is distance from x axis, this part is distance from x axis and it is y, it is y unit. Distance of the point p x y from x axis is y unit and we have taken y positive. Similarly, as this distance is x unit, so we can say this PM length, if PM is perpendicular to y axis, then this length will be x. That means, distance of the point p x y from y axis is x. In this case, as we have taken x positive, y positive, so we can say x is a distance, y is a distance. If in general you are given with a point p x y, if p x y is any point on r square, means it may be in first quadrant, it may be in second quadrant, it may be in third quadrant, it may be in fourth quadrant, then distance of p x comma y from x axis, distance of p x comma y from x axis is equal to modulus of y coordinate. In this case, you can see the y coordinate was y is positive. So, distance from x axis is mod y, which is same as y here, because y is positive. For positive numbers, the modulus is itself. For negative numbers, this will be minus of minus 10, means 10. If you take modulus of minus 10, the value will be 10. As distance is a non-negative quantity, that is why we are putting modulus. So, distance of the point p x y from x axis is modulus y coordinate, and distance of the point p x y from y axis is equal to modulus x coordinate, Now, students, dear students, tell me, suppose a point lies on x axis. Suppose a point lies somewhere here. Say this distance is a, suppose. This distance is suppose a. A is obviously positive because we are in the positive part of x axis. So, let this be a units. Now, if this is x, then x coordinate will be, if this is a, x coordinate will be a, And what about y coordinate? Ki y coordinate, we know ki modulus of y coordinate is distance of the point from x axis. As the point is on x axis, so for this point its distance from x axis will be 0. Its distance from x axis will be 0. Distance from x axis is 0 means modulus y coordinate is 0, that means y is 0. So we can say ki any point on x axis is of the form a0, suppose, or x0 you can also write. Any point on x axis is of the form a0. Similarly, any point on y axis, if you take any point on y axis is of the form what you will do? Say for this point, this length, if it is suppose b, distance of this point from y axis is 0 because the point is on y axis. So distance from y axis means modulus x coordinate, that means modulus x coordinate will be 0 or x coordinate will be 0. So the point will be of the form 0b. The point will be of the form 0b. What I mean to say, ki any point on x axis has its y coordinate 0. The y coordinate should be 0, and if a point is on y axis, then the x coordinate should be 0. This x coordinate should be 0, and this b can be any real number, this a can be any real number. We are here in positive side of y axis, you can move in the negative side of y axis also, but the nature will be same. This b can be positive, negative or 0, this a can be positive, negative or 0. So origin O will be what? This is on both the axes. Origin is a common point, it is on x axis. On x axis means y coordinate is 0, it is again on y axis, that means x coordinate is 0. So origin has coordinates 0, 0. Now let us do some problems. Suppose let the abscissa of a point be 4. Let it be at a distance 3 units from x axis. Let it be at a distance 3 units from x axis. What is the point? What is the point, or what are the points? You may get more than one point also. What is the point? How to see? You see, the abscissa means the x coordinate. So let the point be x comma y or px comma y, give it a name. So given x is equal to 4 because abscissa means x coordinate, so x coordinate is given to be 4, and y coordinate is not given, rather it is given ki the point is at a distance 3 units from x axis. Now distance from x axis, distance of the point from x axis is equal to 3, it is given. Now distance from x axis means, that implies modulus of y coordinate modulus of y coordinate is equal to 3. Now if modulus of y coordinate is 3, what will be y coordinate? That means y coordinate will be plus or minus 3, and y coordinate we have taken it y. So our y has now got two values, one is plus 3, other one is minus 3. So what will be the points then? Value of x is given to us and we have calculated value of y to be plus or minus 3. Now we write the point, we have taken the point as pxy. So the point can be x coordinate 4, y coordinate 3, or x coordinate 4, y coordinate minus 3. That means we will get two such points having x coordinate 4 and at a distance 3 units from x axis. Now let us move to another problem. Say here x coordinate was given and we found y coordinate from the condition given in the question. Now suppose say if a point is at 2 unit from x axis and 3 unit from y axis, then what is the point, or what are the points, Here no coordinate is given, only condition is given ki for the point is at a distance 2 unit from x axis and the point is at a distance 3 unit from y axis. So for that what we do, let the point be xy, suppose pxy. Say distance of the point from y axis is equal to 3. That means distance from y axis is modulus x coordinate. Now if modulus x coordinate is 3, then x will be what? Then x will be plus or minus 3. Again what is given? Ki distance of the point from x axis is equal to 2. That implies modulus distance from x axis means modulus y coordinate and our y coordinate is y here. So we write mod y is equal to 2. Now if mod y is equal to 2, then y will be plus or minus 2. Now tell me how many points you will get. We have plus or minus 3 as x coordinate and plus or minus 2 as y coordinate. That means we will get 4 such points. So the 4 points are we write 3 2, 3 minus 2, minus 3 2 and minus 3 minus 2. These will be the 4 points as per the condition given in the question. Now let us move to an important formula called the distance formula. Distance formula. It is used to find the distance between 2 points on the Cartesian plane. distance formula is used to find the distance between 2 points on the Cartesian plane. Now let us take 2 points then. Suppose we are given with 2 points, say this point is P x1 y1, this point is Q x2 y2, and we have to find the distance PQ. Now to find the distance, you see, drop a perpendicular from P onto x axis, suppose it is A. So you can see as the point is x1 y1 and we are dropping a perpendicular here, that means this distance from OA, this distance from O to A, OA will be x1 and PA will be equal to y1 or not? OA will be equal to, this distance will be x1 and this distance will be y1. Similarly, if you drop a perpendicular from Q on x axis, suppose it is B, then from O to B, this distance will be x2 and this distance will be y2, because the coordinates are x2 y2 and we are dropping perpendiculars. So from origin to B the distance will be x2 units and from Q to B this height will be y2 units. Now drop a perpendicular from P onto QB, let us take it C. Now for this perpendicular, now you see this APCB becomes a rectangle. So our, let me write here, OB is equal to x2, QB is equal to y2. Now AB is equal to, you see, AB is equal to OB minus OA. AB is equal to OB minus OA, and OB is what? OB is x2. OA is what? OA is x1. So AB is x2 minus x1. That means we can say PC is x2 minus x1. So that is same as PC. Now we will calculate this QC. You see, QC is equal to QB minus BC, and QB, the total length is y2. BC, as this is a parallelogram, APCB is a parallelogram, if PA is y1 unit, then CB is again y1 unit. That means what remains? QC, this portion will be of length y2 minus y1. So QC is equal to y2 minus y1, this QB minus BC. Now once you get PC and QC, you see that is a right angle triangle. That triangle PCQ is right angled. So triangle PCQ is a right angled triangle, is a right angled triangle with right angle at, with right angle at what? With right angle what? At C. That means if you apply Pythagoras theorem, what do you get? Ki PQ square is equal to PC square plus CQ square. Now we have everything with us. PC length is there and QC length is there. QC means CQ. Say PC is x2 minus x1, its square, x2 minus x1 square plus y2 minus y1 square. So this is PQ square, and we want what? We want PQ. We want PQ. So PQ will be equal to under root x2 minus x1 square plus y2 minus y1 square. So, this is called the distance formula. Using this formula we calculate the distance between two points on the plane of r square. The points can be in any quadrant. For simplicity we have taken it in first quadrant, but actually the formula is valid for the points lying in every quadrant. So, this is the distance formula. Sometimes we write mod pq. In some books you will get this notation, mod pq as the distance. No problem, you can write also pq, you can write also pq within bars. Now tell me, can you write pq is equal to square root x1 minus x2 whole square plus y1 minus y2 whole square? Yes, we can write. Why? Because a minus b whole square is same as b minus a whole square, square is there. So, we can use this formula, or we can use x1 minus x2 whole square plus y1 minus y2 whole square. Both the formula are correct. Now, suppose one point is P, other point is origin, other point is origin. So, what is the distance of the point P x y from origin? There you can see the distance OP will be equal to, if you apply distance formula, it is x minus 0 square plus y minus 0 square, that is square root x square plus y square. So, distance of the point P x y from origin is square root x square plus y square. You can also do this by applying Pythagoras theorem. How? Say if this point is P x y and this is y, this is x. So, what about the hypotenuse? This hypotenuse OP will be under root OA square plus AP square. Anyway, this will be coming as square root x square plus y square. So, distance is non-negative. Distance is a non-negative quantity. In no way we can say distance is negative. Distance is always a non-negative quantity. Distance can be 0, but distance can never be negative. Now, suppose we have points like x1y and x2y. Let me give it a name. Suppose B is equal to x2y, A is equal to x1y. What will be the distance? If you can mark one thing, the y coordinates are same here. In both the points, the y coordinate is y. So, what will be the distance? In such a case, directly you can write the distance is modulus x2 minus x1. Directly you can subtract the smaller value from the larger value, or we can write here modulus x2 minus x1, because we do not know which one is larger. So, that is why we are using modulus sign here. If values are given, suppose you are given with 4 3 and 5 3, then directly you can write distance is equal to, directly you can write distance is equal to 5 minus 4, that is 1 unit. Directly you can write this way when your data is given in numbers. Similarly, if A is xy1 and B is xy2, that means the x coordinates are same, you can see the x coordinates are same, the y coordinates are different, then what will be the distance in this case? In this case, simply this will be y2 minus y1 modulus. If you apply distance formula, what do you see? What do you get? You see that will be x minus x whole square plus y2 minus y1 whole square square root. Now, x minus x becomes 0. So, ultimately we are having y2 minus y1 whole square square root, and this is modulus y2 minus y1. You can apply distance formula or directly you can use this as a rule. Now let us find out the distance between 2 points using that distance formula. Suppose A is 4 3, B is suppose 1 1. What will be the distance AB? Then distance AB is dash unit. How to calculate? Say A is equal to 4 3. Suppose this is our x1 y1. Suppose B is 1 1. Say this is our point x2 y2. Now AB distance is under root x2 minus x1 square plus y2 minus y1 square, and square root is there. So that will be, now you put the values, x2 is 1 minus x1 is 4. So 1 minus 4 whole square plus y2 is 1 and y1 is 3, and you take the square root. What you will get? You see, this will be minus 3 square plus minus 2 square, that means square root, so 9 plus 4, that will be root 13 units. So the distance between these 2 points is square root 13 units. Now let us do another problem. So these 2 points are in first quadrant. Now let us change the quadrants. So now suppose we take A is equal to minus 1 minus 2 and B is equal to 2 minus 3. B is equal to 2 minus 3. In this case, what will be the distance? In this case, what will be the distance? Say our A is minus 1 minus 2. Let us take it x1 y1. B is 2 minus 3, that is x2 y2. Then AB distance will be square root same x2 minus x1 square plus y2 minus y1 square. We have taken the square root again. So square root of what? x2 is 2 minus x1 is minus 1 here. So minus 1 let me write, plus y2 is minus 3 minus y1 is again minus 2. So what you will get? So that's square root of, this will be 3 square plus this is minus 3 plus 2 means minus 1 square. That means you will be getting square root 9 plus 1, that's square root 10 units. So this is the distance between 2 points, and this point is in third quadrant, this point is in fourth quadrant. Now suppose we take another problem. Say varieties of problems are there in distance formula. You will get varieties of problems. If the distance between the points x, 3 and 4, 5 is square root 40 units, suppose, then x is equal to dash. What is the value of x? The distance between x3 and 4, 5 is root 40 units. Then what will be the value of x? You see, suppose A is x3, B is 4, 5, then AB is square root 40. That means you will be getting what is AB? Square root of 4 minus x whole square plus 5 minus 3 whole square, and in RHS we are having square root 40 unit. Now if you take square on both sides, this will be 4 minus x whole square plus 2 square, that will be 40. So that 4 minus x whole square will be equal to 36, or 4 minus x will be equal to plus or minus 6. So what will be x? X will be equal to, or 4 minus x will be equal to 6, or 4 minus x is equal to minus 6. That means 4 minus 6 is x, or 4 plus 6 is x. So we are getting x is equal to either minus 2 or x is equal to 10. So let us wind up here. This much for today. In the next class we will see the area, how to find area of a triangle, how to find what is the section formula, all those things we will discuss. This much for today. Thank you all.
ଏହି କାର୍ଯ୍ୟକ୍ରମର ସହ ପ୍ରାୟୋଜକ ଥିଲେ